Hi. So no long introductions about who I am. Just to say, I've been a programmer for many years. Most of my life as a programmer, I admit I've been much of a hacker, really. And I'm guilty of writing systems that overcharge people, that undercharge people. Unfortunately, it wasn't the same group of people that were overcharged and undercharged, but worked out all right for the company. Anyway, this talk is essentially about what I feel is an often neglected and misunderstood aspect of BDD, the middle D in BDD, the driven aspect. So it's about driving software from examples, or even deriving software from examples. And it's also about solidifying that loose connection between business requirements and the code that we actually produce at the end of the day. So it's about making sure that every step of what we do is also driven by the step before it. So in agile practice, requirements are always vague and incomplete. I mean, who doesn't work in agile practice these days, right? Well, the thing is, nobody knows exactly what agile is. That's why nobody's putting their hand up. And that's because the business themselves only have a vague idea of what they want to build to start off with. But that's fine, because that's sort of expected in agile, since the idea is supposedly not to plan up front too far. But part of the agile process has to be a kind of discovery of the requirements, right? So that in theory, at least, we have something more concrete that we can pass on to the developers to start working on. Because we, as developers, need to be given concrete requirements, because if we're not, we start making up all sorts of stuff. So requirements, unless you work in academia, usually come from a new business goal. So imagine a courier company called Deliveryto that up until now scheduled couriers manually. And they've decided to move away from manual scheduling because they can only handle about 100 deliveries a day. And it's complicated because the team has to take booking calls from the customers, check the courier schedules on the walls, pencil in the customer if there's a courier available, and then they have to check if there's a closer courier to the customer at that particular time. So there's more than several dozen couriers a day. It all goes wrong, and what's more, they're losing out to competition, and they've decided they need an app like Uber, right? Because that will solve all their problems. So the instruction comes from the top. I mean, this is a form of requirements, right? And then there's the product owner, who's also the guy with the vision. And he sees clearly what kind of system is needed. And he's visualizing something like the Uber app for some reason. And this really cool interface allowing hundreds of couriers to be cleverly scheduled for pickups and drop-offs. But his vision is unfortunately not communicated across very efficiently to the developers. The product owner knows the project is potentially complex, but conveying all of that complexity to the tech team is challenging, to say the least. Having a vision and a goal for software application is all very well, but when the business knows nothing about software development and developers have no idea what the business needs, then we have a potential problem. Especially in the case of very complex requirements. Moreover, the business person and developers rarely even speak the same language, because the business people talk in terms of dollars and profit and loss, and developers talk in terms of code and messenger queues and so on. So transmitting requirements across this infamous communication gap almost always results in real business leads getting lost in translation somewhere. So the product owner says, yeah, I want all of this stuff, and she's trying to convey this to the team in one fell swoop, because she knows what the business rules are. I mean, at least she wrote down a lot of stuff during the meeting. And she wants to convey all this understanding in one conversation. But it's difficult because the rules are very complex, and she's not interested in the technicalities. On the other side of the conversation, we have the developer team. And what they actually understood is another matter altogether. They have a vague idea by now, at least it should have a big green button which notifies the courier, and then courier gets booked or scheduled or something like that. But where to even start? So the team go back to the PO and complain the requirement's not clear, and they're not even sure where to start. So the product owner, in order to try and convey this in a slightly more technical manner, uses a business analyst who writes a basic user story. You've seen user stories like this. Quite useless. I've worked on a team where we were presented requirements that look pretty much like this. But the acceptance criteria is so vague that the team can't even start working. So they start asking questions. And the BA just says they don't know. They have to go back to the PO. The PO hadn't even imagined this scenario and has to go back to the stakeholder. And the thing is, it's quite common for the team to start building an application at this point, despite having no idea of what it does. But getting into the coding at this stage can lead to a lot of wasted time. I mean, coding is hard and very time-consuming. Therefore, it's critical that devs know precisely what the goal is, because it's hard enough coding to a known goal. Coding to a goal that's on shifting grounds is a nightmare. So where are the dev team right now? Well, they're lost in the swamp of sadness. This is the swamp of sadness from the never-ending story. And they're sidetracked. They're arguing about whether this should be a React app and what the booking actually does. And they've got some really cool ideas about connecting to Google Maps and using all these complicated APIs to calculate distances and so on. But in reality, they're completely lost, completely off the track. So what I'm trying to get at in this talk is that instead of sort of meandering with the hope of hitting the right goal, can we imagine a saner way of working where every step of the way is driven by the step before it or by the goal? And what does it mean for software to be actually driven by something? For the actual code that we produce to be driven, what drives the code? The requirements from the business analyst. What drives the requirements from the business analyst, the product owner? What drives the product owner? There's some goal from the business, right? So, since we want the application to be created in order to fulfill this business goal, we'd like to see application code directly driven by the goal, and therefore, each step in the chain needs to be driven by the previous step. I'm just going to go briefly into this part of it, and then we'll go into something more technical. But BDD, which I mentioned before in this talk, which is essentially what this whole thing is about, has now sort of claimed the business ground as well as the technical, and promotes an idea that goes something like this. The business goal drives an activity called impact mapping, which drives an activity called example mapping or feature mapping, depending how complex the application is. These drive executable specifications, which drive the application code directly. As you can see, these are two different spheres. One's a more social activity, the other's a more technical one. But the idea is that through this whole process, we have this driven aspect. One step is driven by the other. But between the example mapping and the executable specifications and the code that comes out at the other end, some sort of magic happens, because some code emerges that satisfies business requirements and is therefore a software model of one part of our business. So one aspect of the business, one domain, has been automated and modeled in a computer language. And that computer language is completely incomprehensible to the people requiring it. So therefore, I think it's important that we maintain this link up the chain. So the guy that introduced this idea called impact mapping, called Gojko Acik, and a lot of his anecdotes about experiences of developers being told that the feature that they've been working on for 6 months is just not needed anymore because the business realized that they don't need anything like this despite having spent so much money. So it's about poor communication of objectives and misalignment of goals. And his proposal is to work from the business idea, the big why, and have a giant sort of brainstorm, a mind map, with many of the stakeholders involved who can help, branching out of that into how they can help, and branching out of that into what they can do that will actually support this business goal directly. So in the case of Deliveryto, it would work something like this. They want to scale deliveries by 500%, say, within the next 6 months. The people involved might be IT operations, marketing, couriers, customers, and they each have their how. Right? IT operations obviously automate the booking system, email campaign. And when they look at the deliverables that they can get from automating the booking system, they realize there are actually 3 separate things that can be produced, and they're not all as important as each other. So in fact, the mobile app is the least important. What they want is a scheduling system, which could be just an API, and until then, they could just have a web form with a button, or people still call up, but they use the API, which is the booking engine. The couriers don't need a mobile app to start with. They can be updated via SMS or phone call. So they reach a consensus, and everyone's happy that they have their first deliverable, which will be a software system written in PHP, and will automate the booking system. But at this stage, they've never built anything of this scale, and they're faced with 2 big problems. How do they extract all the business rules and features of the system so that the team can understand them? How do they convey this critical information to the programmers that build this thing? Okay, it's not 2 things, it's 1 thing basically. And if there are no guidelines, this is what happens. So the developers enter into a sort of misty fog because they don't have clear criteria, they don't know exactly how this application is supposed to work. And they've decided to create what they remembered the product owner saying in the last meeting, and they build a superbly engineered solution. The problem is that the requirements they had were sort of half imaginary, because the bits they didn't know, they filled in themselves. What do we do to avoid this? I want to talk about how we can use examples to sort of blow away this fog, this mist of ambiguity. And examples are descriptions of how a user would actually use a specific part of the application. There are also examples of outcomes of different scenarios. They're completely concrete and they use real data. And though it might seem obvious to jot down examples during a meeting, most of us think that we can come up with the examples later, because if we know the business rules, hey, we can make the examples up, right? Problem is, once you actually start writing down examples, all sorts of other questions arise. And then you come up with more examples. And when you've written 2 examples down, another possibility arises. So, that's why it's important to try and hammer out these examples with the people that know the answers right there and then, and answer the questions. But often getting to the actual real examples is the most difficult part. But there are many ways that we can elicit examples from the product owner. As Liz Keogh says, the best way to get the PO to give you an example is to say to them, can you give me an example? It's that simple. So if the product owner says, well, we've got this business rule. If the courier can make it in time from last drop-off to the next customer, then they're scheduled for the job. So we simply say to them, can you give me an example? Because that's not an example, it's a business rule. So this is Liz Keogh's definition of BDD, which of all the various and strange definitions, this is the one that I gel with the most. It's the art of using examples in conversation to illustrate behavior. And it's hard to emphasize how important clear-cut examples are in this context. Because we aim to reduce the amount of information that gets lost in translation. And without concrete examples, we're lost. That's not to say this is the only way of dispersing the fog. For example, event storming is a popular method of discovery. I don't know if you've heard of event storming in DDD. But event storming also eventually leads to examples, but they're described in terms of business events, and it helps to visualize the timeline of the system and understand what happens when. So what's an example? Is this an example? A customer books a delivery. Deliveryto checks to see who's available for that time, schedules a courier, and the courier gets scheduled for that time. The customer then gets the notification. It's something that approaches an example, but it's more like a description of the business rule. What happens in this case? What happens in that case? To make it into a more concrete example, we personalize the people involved, use real addresses and real times, and by doing that, it helps us imagine the scenario a lot more clearly. So James books a delivery from Den Haag to Utrecht for 1 o'clock. Nix, who works as a courier, was scheduled earlier. And now we see, or we start to see, why he won't make it to the pickup. But we can go even further than that, because there'd be some details missing from this, right? Nick works as a courier. His average speed is 20 kilometers an hour. He was scheduled earlier, picking up from Amsterdam, which is 10 kilometers from Den Haag, and delivered to Den Haag. And then we know that it takes him half an hour to travel 10 kilometers, and he will be available to pick up from Den Haag. And the more clear-cut and concrete our examples are, the easier it becomes to move from this to actual code. So this is Gojko Atsik again, the guy who wrote the book about impact mapping. He wrote a very good book called Specification by Example in 2011. And if the idea behind BDD started around 2004, he felt but by then it was already too misunderstood or misapplied, and he avoided using the term altogether. And he calls it specification by example, but it's essentially the same thing. And his point is that everyone can invent their own example, but there's nothing to prevent, nothing to ensure that they're consistent or complete. To avoid this misinterpretation, we have to make sure that we maintain one source of truth. and avoid playing the broken telephone game. So that is, we write down those examples and they become holy. They are going to be the things that drive the actual code. Sorry, so a way to get at those examples without writing down technical scenarios to start with was proposed by a guy called Matt Wynn from the Cucumber Company, and he called it example mapping. It's a sort of group activity, a cross between a social activity and a business meeting, where the output is concrete examples of the requirements. And the point is that everybody is standing up, you're not using a screen, so it's slightly less alienating for people who are non-technical. And we think differently when we're standing up as well, everybody's more engaged. And it's the right time to ask questions about the details of every example. And the way he describes it is like this. He puts a card up in one color, which represents the feature that they're going to be working on. And next, they need to identify some business rules to do with this feature. So for example, the simplest business rule that the PO was able to identify is that if no couriers are available, the customer is simply told that they can't book. No messing about. But what's an example of that rule? What does it look like in practice? Okay, so he proposes writing examples underneath the business rules in yet another different colored card. And I'm putting here facts and information which sort of supplements this example. The couriers go 20 kilometers an hour, distances between places. And then we can see clearly from this example that because Nick was scheduled to deliver from some place to some place for 2 o'clock, then he won't be able to make it to Den Haag at 2:15. And there's another slightly more complex example of the same rule, which is when his drop-off point is not exactly where the customer wants to pick up from. So this does entail another slightly different example, which when transformed into code will yield slightly more complex code, right? Because you have to calculate another leg of the journey. So then they go to the PO. Okay, so what's an example of a courier being booked? So courier gets booked if his job leaves him enough time to get to the pickup point. So we specify exactly what happens, the outcome being that Nick is scheduled and James has the pickup confirmed. Is that the only possible outcome? What if there are more than one courier, they say to the PO? Okay. In that case, we have another business rule. If both couriers happen to be available, we're going to pick the closest one. So let's see, please, can you give us an example of the closest one being picked for a job? Okay, so here's a very complex example. One of them will end up in a place that's slightly closer to the pickup that James wants, than the other courier. Therefore, he gets scheduled and Nick is not scheduled. That should also be written down as the acceptance criteria. And from here, we go to something called executable specifications. So we don't just collect all these cards and then say, okay, now we understand it, and throw them in the bin. No, we take them as holy writ, and we translate them to executable specifications, which are simply specifications are executable, right? They're written in plain business language. They're often written in English. They don't have to be, though. Each line represents a step to be interpreted by the computer. And the specification talks about one thing happening, while the computer checks that that thing actually happened. And the important thing is that these executable specifications are easily understood by both the developers and by those who don't have the technical language to understand it. In other words, these specs become a sort of living bridge between the dev team and the business, because they are still worded in exactly the same way that the examples we previously saw were worded. So a quick word about this given, when, then formulation. This is an idea that Dan North came up with together with Chris Matz and Matt Wynn back in 2004. And it grew directly out of the idea of test-driven development. I'm sure you'll recognize the methodology in a moment. And eventually this format came to be known as Gherkin, a line-based list of steps that can be passed and executed. But Gherkin was never meant to convey a sort of user journey, like given the user is on the home page and then clicks through to the support page, when the user fills out the form and a dialog box opens and the user clicks OK, and then they should be on the confirmation page. That's a user journey, right? Given, when, then is simply this. Given something happened in the past, when this action is taken or this command is given to the system, then some outcome should have happened. That's it. And if anybody's come across this idea in TDD, in unit testing, there's a very similar idea called arrange, act, assert. Arrange for the system to be in a given state, take the action to test, and assert that the resulting state is correct. Right? So let's have a look at this executable specification. But before we go into how this actually gets turned eventually into code, I want to point out a couple of interesting things. This is precisely the area that behavior-driven development crosses over with domain-driven design. And if you know anything about DDD, talks about a lot about distilling concepts from the domain, identifying them, and building a domain model from those concepts, right? But imagine you have several scenarios like this, and business concepts start to suggest themselves and to emerge. So, in fact, these examples become your sort of domain model themselves, because in the language is also encoded the relationship between these concepts. Right? James, who's a customer, books a delivery. Couriers are available. Distance from one place, distant to another place. So you get all this before you even start programming. And some people even go as far as meticulously making sure that they use the same language in the examples as in the code itself, which for some people is the aim of domain-driven design, to have the concepts of the business filter through all the way into the code. So what would it mean to execute this? Well, how we get the distance is none of our concern. Maybe it's Google Maps, but we set up a stub response for now. Courier speed is constant, at least for these examples, so we can hard code it. At this point, we need to create a schedule for Nick, so that the system already has a schedule for him, right? So that when we execute the action, we make the actual request to the system to book the delivery from this pickup address, and we want to see what happens. So what happens is then we assert that Nick was scheduled, was not scheduled, and that James is told why. Now, this actually gets wired in to an interpreter called bhat, which is the PHP equivalent of cucumber, and a context file which takes each line from this executable specification and turns it into code. So let's imagine this context file having a system, which is the Deliveryto system, instantiated with various dependencies. And we're saying that given the distance from one address to another address, simply sets up this stub for us, which we will swap out in a real system. Then registering a courier and registering a customer in the system. Okay, given Nick was scheduled means that we have access to the schedule. We put Nick into the schedule by adding a delivery which we make up from the times and addresses. So we've set up the system in a known state. Now we can try to book. So the line for booking the delivery looks a bit like this. You create a delivery and use the system to try and book this delivery. At this point, we are running the code purely through the domain model, not through a real request response. So we have to catch the exception from the system because we'll want to inspect it later. So we want to check that delivery was scheduled. We check that the schedule that the system uses has had the delivery added to it. We checked that the messaging system sent the message to the customer. And when we run the code, when we run this executable specification, we get told that the delivery was not booked. Of course, nothing happened because the book method is empty, and we need something in here to make the actual booking happen. Remember, we were just trying to fulfill each little line of the example one at a time. So booking a delivery at this point is just adding the delivery to the first courier. We only have one courier. That passes that step, but it fails the next one, saying that James should have received a message. Okay, so we need the message gateway and send a message to the customer. And that passes that one. Okay, with this little bit of code, we've got basic scenario running. But the problem is when we go to the next scenario, it's expecting to reject the booking. Of course it doesn't, because it always books it. So we have to write a little bit more code that checks to see if we can now take this booking. So there's a bit of hacky code. Some of it's gone into objects. But the key point is that it's introduced a conditional, of course, because if the pickup time, if the estimated pickup time for the courier is before the delivery request, then we're fine. We can book the courier, at least for these simple cases. Otherwise, we throw an exception. And for this, we get the scenario passing now. So now we can book, and we get rejection when he can't be booked. Now we can tidy up the code a little bit by moving some of the behavior into the actual objects, like moving the calculation into the delivery object. It's a little bit more readable now. And the good thing is that we have scenarios that we can run. We run them again, make sure they still pass. But when we get to the third scenario, which involves calculating the third leg of the second leg of the distance, if they're not going to make the booking on time, requires doing another addition, going from where the courier last dropped off to where he's going to pick up. So we write a little bit more code, right? Add the transit time, and then we pass the third scenario. And since we have 3 scenarios running, we can safely refactor. Refactor it a little bit, make it a little bit more readable, and make sure all scenarios pass. Now, what in fact we've ended up with here is a little code domain model. And the domain model is actually represented by the examples. And some people go as far as to say that these examples are in fact the domain model itself. in terms of code, what we ended up with is a few classes, like 9 or 10 classes, and they represent the domain model that satisfies these 3 requirements that we had. Now, you've noticed that I haven't run them all the way through the API right through the database. It's just running through the code itself. So thanks to flexible frameworks like Symfony, we can easily wire this domain model in to the framework and then run bhat using a different profile. This different profile causes the steps to be interpreted differently. And what we do is that when James tries to book a delivery, what we want to do is make a real request. That means adding a controller that has a route for booking, for example, and having test services that we can swap out when we're running in test mode, and bhat runs in test mode by default. Okay, so then you can run exactly the same scenarios again. You can be sure that they will work in the same way, but at different levels in the domain model itself, and all the way from the API through to the database. So to summarize, we started with having a business goal and went to something called impact mapping, which drove example mapping, which then produced something like this, which drove executable specifications, which drove the application code that we wrote. And what would be nice is if there is a clear link going from one to the other, especially at the 2 last steps, because this is where the actual business requirements get translated into code. So it's really, really critical that we get that last transition right. That's why it's important that we write the examples in a very concrete form and translate them directly into code. That's basically it. But last but not least, I want to mention something called living documentation. Also from a.k.a. and John Ferguson-Smart, who've written books about it. Talks about, how in Agile people don't bother documenting very meticulous anymore because it changes too quickly. And these forms of executable specifications can leave something behind. They can leave reports. These reports can be generated in HTML or whatever. If they're written in a way that reflect the precise business requirements, they form documentation that is kept up to date all the time, right? In bhat Cucumber, you can do it via extensions. Serenity, BDD is built in. Concordian is a different idea. They take Markdown and they execute the Markdown directly. Each part of the Markdown is linked to a different bit of code. On a project I worked on recently, I created living documentation for them that looked like this, where it has the business rules and the features, and you can drill down into each of the features. On the left you have the business rules, on the right you have the given when then, but in a way that's hopefully a little bit more accessible and looks a bit like documentation. Serenity BDD looks like this, and with Concordian, which is Markdown, it can look like anything, of course. Some highly recommended reading by all these people, and I'm going to publish this on slide deck so you have access to this. That's it. Thank you.